Number 2, a covalent bond consists of, right, so we're a covalent bond, so it's not a transfer, right? So there's no ions involved. That would be an ionic bond if there was a transfer and ions involved. But this is a covalent bond, so it's going to be sharing. We're going to be sharing electrons. And so because we know we're sharing, we can eliminate options C and D right off the bat. 2 different ions. No, this isn't ionic bonding. We're not talking about ions. An octet of electrons. We're always trying to achieve an octet of electrons. So that might not be the worst option you could choose, but it's definitely not the best. Definitely not the best. Because this question is asking about the bond specifically. If I were to ask a general question about the 2 atoms involved in a covalent bond, yes, maybe we can say that each of those atoms has an octet of electrons, because remember, that's the driving force that pushes, that drives bonding to satisfy that octet rule. But we're not talking about each bonded atom individually or as a whole. We're talking about the bond itself. And so when we're talking about shared electrons, we have 2 options here. We have A and B. And this might seem like a cheapie, but it's actually kind of important. A says a shared electron. A shared electron. That is incorrect. It takes 2 to tango. You have to have at least 2 electrons. At least 2 electrons. Now, if you're going to involve a double bond or a triple bond, you'll have more than 2 electrons shared, but it's always going to be in multiples of 2, right? One bond is always going to consist of 2 electrons. An electron pair, both of those electrons are shared, not just 1 electron. So the correct answer is B.